to introduce a little bit our chapter of Leading Cyber Ladies. So you can go to the website leadingcyberladies.com to learn more about us and different regional chapters that we have. We are online right now, so join whichever fits your time zone. Today, we welcome you to our Canadian chapter. My name is Helen Oakley, and I'm co-founder of Leading Cyber Ladies. Today, Neetika wasn't able to join, but next time she will also join. I'm sure many of you know Neetika as well as a co-founder of Leading Cyber Ladies Toronto. Now, we like to inspire women to pursue their goals in cybersecurity. We want to amplify their voices. You know how to get in touch with us if you would like to be a speaker or if you would like to bring more ideas or comments about any of our session. So welcome again, and let me introduce Michele. I work with Michele at SAP. Michele is part of SAP SuccessFactors, and we have many discussions on security. We laugh, we cry, and it's always interesting. Michele, I'm looking forward to your session today. So take it away.
Thank you, Helen. I've had so many technical difficulties today. The computer is not my friend. So today it's container security, all about the supply chain. Again, I'm Michele Chubirka, Chief Security Architect. You might know me as a professional contrarian on Twitter. I'm the creator of the former Healthy Paranoia Security podcast and Security Sock Puppets. Tons of fun. Please enjoy it. I'm an analyst, or I've been an analyst, a researcher, blogger, B2B writer for publications such as UBM and TechTarget, General InfoSec Bene Gesserit. I pontificate frequently on security architecture and best practices. You are welcome to check me out at postmodernsecurity.com or on the Twitter sphere as Mrs. Y is Y. So let's start with the software supply chain. What? Containers are software? Yes, they are. So for those of you who aren't familiar, this is a pretty standard software development life cycle. You might see the infinity symbol. That's another way of rendering it, but plan, code, build, test, deliver, deploy, and monitor. I've included some standard tools that you might see in your environment so that you have an understanding of where those fit in. Basically, an SDLC, or a software development lifecycle, is a set of processes that build a product. You may also know of it as you'll hear CICD, right? Continuous integration, continuous delivery, or deploy. A lot of times those are interchangeable. That's another placeholder for what you might know as the SDLC. But here's a view of the container supply chain. So let's take it something that you might build, a developer might build a WAR file, right? Which is a set of Java packages. You have the build and test section for that WAR file. I've indicated that it's the software pipeline. Then you're going to take that package and you're going to add it to a container image, right? Now you may use a base image, you may build your container image completely from scratch with Builda, but then you're basically, what I like to say is that a software pipeline is really a set of pipelines, because you see that you have a software pipeline and a container pipeline, and they interrelate. And the software pipeline creates the item that then is going to be added to the container pipeline to create as part of creating the image. You're going to test the image, and then you're going to publish that image to a public repository or an internal repository. One thing that I found that I think is going to be helpful as we talk about supply chain security and the container supply chain is from the Salsa security framework. It's from Google, but now it has additional contributors from other industries. It identifies every point in the supply chain where you will have a different kind of threat. Let's walk through it. For example, you have source code review, or either automated or manual, and the bypassing of that. Another threat would be where you compromise the source control system, or you have developers who maybe don't use it at all. C, somebody modifies the code after the source control system or outside of it, and then it's introduced into a pipeline, a software pipeline. May have a compromised build platform, your Jenkins server, for example. You might, at phase E, you have a bad dependency. We all know how the components of software, the open source software packages, can either be compromised or they're just vulnerable. You could bypass CICD altogether. There is the potential for a compromised package repository, or just using a bad package. Here's an example I thought would be super helpful from, there's a NIST paper called Defending Against Software Supply Chain Attacks from this year. And what they've done is they've gone through each phase of the supply chain, and they've provided an example of very high profile kinds of attacks. I think we all know about the SolarWinds one from 2020 that has been pretty catastrophic in terms of the impact to government and private industry. But there are also some blasts from the past, like Kaspersky antivirus, backdoors in maintenance updates. I mean, I've seen a lot of these over my 26-year career, but I think SolarWinds is the most, is the top of everyone's mind because it was so impactful. So supply chain security, let's talk about the ways that you need to think about securing your supply chain. So what you're doing with supply chain security is you're adding assurance to the software development process. You're creating confidence and trust in the source material and the practices or the processes involved. I'd like to say that you're taking a holistic view to protect each stage in the software development lifecycle. So it's not tools focused. I think that's really important. I've mentioned some tools here, mostly because it helps, contextualize what we know, right? But it's really about business processes. That's what the SDLC is. It's just a set of business processes that make a thing that we know of as a container or software. So adding security is you're validating that the final product meets a reasonable set of security criteria to ensure that it's not vulnerable. Because this is important to customers, whether they're internal or external to your organization. So, and again, as I mentioned, although not new, this is not a new topic. Because of recent high impact attacks like SolarWinds, it's heightened the attention on software supply chains, especially by governments and large private sector organizations such as finance. Banks are very interested in this now because they are a high value target, as well as government. So let's go over some really exciting stuff. This is going to get a little dry. I'm sorry for that, but we're going to go into the details of what a container is, because I think that's important to understand how you protect the supply chain and you protect and advocate for the security of a container. So what is a container? A standard unit of software that packages up all the code and all its dependencies. That's really what a container is. I think a lot of people have some misunderstandings and they equate it with a virtual machine, but we really need to understand it for what it is. It was just a tool to make a developer's life easier, and it's intended to be lightweight and portable. As I mentioned, a lot of people sort of have confused virtual machines and containerization. Containerization actually is not a recent concept with LXC. It actually started on the Solaris platform, and you even have this idea of containers to some degree on mainframes. But today it's kind of referred to because of the popularization of Docker as a Docker container, right? So let's talk about the differences between a virtual machine and containerization. The key differences is whether or not you have a dedicated kernel. And that's really important to remember. In a virtual machine, you'll notice that you run on a hypervisor, and each one has its own operating system. So each one has its own kernel. In containerized applications, they all share the same host operating system, so they're sharing the same kernel. Now, why is that important? Because it presents a different attack surface. It makes if you utilize container escape, now every other container on that host operating system is vulnerable to attack. So it makes it dangerous. I'll frequently hear people talk about containerization as isolation, and that's my pet peeve, because it really isn't isolation. It's segregation. More in line with the concept, if people are familiar, I'm dating myself a little bit here, but a cheroot jail cell, right? In the old times in Unix world, you used to do cherooting, which was you would do a fake out where an application wouldn't realize it was sharing a host with other things. And it's a similar idea to that, although it uses a technology called LXC to help partition kernel resources. But make no mistake, you're still sharing a kernel. So let's talk about, and I hope everyone's noticed I'm using a cooking metaphor here, although what's kind of funny is you really don't want me to cook for you because you're likely to be poisoned. But for some reason, I thought it was a valid metaphor. So let's talk about kernel space versus user space. So again, we want to emphasize virtual machines run their own isolated kernels. There's no shared memory or execution space between these guests which run applications. You can, but unless you're actually intending to do this, without the addition of virtual machine technology, you've got Kata, Firecracker, or gvisor, which you can call that, they're often referred to as micro VMs. But unless you're using something like that, containers share the same host kernel. Firecracker is an AWS technology, by the way, that you can deploy on premise. If you're interested, I encourage you to go spend some time researching Firecracker. Linux namespaces, you have techniques such as Linux namespaces, capability restrictions, seccomp, SC Linux, AppArmor, cgroups. All of these tools, they can be used to enhance segregation between running container instances on the host, but it's an enhancement and it can be very complicated. So you need to remember that it's while helpful, it's still not the same kinds of isolation that you would have with virtual machines. I like this diagram. All of these diagrams, by the way, I fully referenced them at the end of the presentation, so you'll be able to research this on your own more. But I didn't feel like it was necessary to reinvent the wheel. So images, basically, container images are file system bundles. They're built of layers corresponding to instructions in scripts or a Docker file. And that's really important to remember. It helps you understand what the attack surface is, how you could hide things in layers. You also need to understand when you're using a security tool to inspect or scan a container, that it needs to be aware of this UFS system, this overlay file system that's used. And that's important also for you to understand that it's a bundle. I'm emphasizing this so much because people will talk, people who don't understand containers, a lot of security people who come from the threat and vulnerability management side of the house will often try to equate it with, like I said, a virtual machine, an operating system, and it references those libraries, and it will make references to operating system mount points and network elements, but it is not, that's not what it is. It's just making a reference to that. So let's also talk about the container runtime and container management tools. Docker has been, I have a love-hate relationship with it, mostly because Docker is to, I like to say that Docker is to containers what Kleenex is to tissues. We frequently interchange the words, right? You'll hear Kleenex or tissue, but we all know that Kleenex is a brand, right? Well, Docker's the same thing. Docker helped provide a tool that made containerization more accessible and more manageable for the developer community by, having this great tool that that made it much easier to package things up. But really, at its heart, Docker is a high-level container management tool. It's not even, it has the container runtime, the CRI, but it's not a container. That's not all it is. It's more. An alternative to Docker, which is a simpler high-level container management tool, is Podman that you'll see on Linux, right? Red Hat specifically. Then you have high-level container runtimes, which is Containerd, for example. Then you will have a low-level container runtime, which is at its heart run C, right? I've also compared it to the Kata runtime or to gvisor, which they're micro VM kinds of technologies. I know that's a lot. That probably made your head hurt, and I don't expect you to immediately internalize all this information. You're likely going to have to, that's why I provided so much material so that you could come back to it, right? So let me give you some TLDR here of what I think is important, what the takeaways are from this. Common misconceptions. These are my pet peeves. That it's a full virtual machine or an AMI. It is not. That's not what it is. It is also not your entire monolithic application stack. If I see a container that's like 2 gigabytes, if you see one that's 2 gigabytes, I want you to hold up a big stop sign. I can tell you right now, if you see a container that's more than like 100 megabytes, you have problems. That is, you've got a problem with your container lifecycle, and you need to take your developer aside and say, we need to talk. A running instance, there's also a differentiation between the image and the running instance. Now, you will hear container used interchangeably, either like they will call the image the container or they would call the running instance the container. I tend to be very pissy about this myself, and I will say the container image or the container instance to be clear. Because remember, a container is just a software package, including dependencies, the libraries, and the application runtime that will run in dedicated area of user space. Now, again, I pointed out all the differentiations between, a virtual machine and a container, and how the kernel space is addressed, because that's really critical in the security of a container in the supply chain. So one of the biggest things that you're going to talk about, one of the most problematic areas, where do you get your container from, right? Let's talk about that, because we all know the dirty secret that developers love to download their containers, a base container image from Docker Hub. We all know this. We all know that it annoys us, but life is easier that way. So let's talk about some of the recipes, right? So you can pull a base image from maybe a public or a private registry and add your code and your configuration, maybe you add a little script or something like that. I have mixed feelings about this. You can treat Docker as a trusted registry. I think they also have validated, you could treat Docker Hub as a trusted registry, and then you can look for validated repositories within Docker Hub. There are various mechanisms for that, for trust, for identifying trust. I prefer personally to mirror those the projects that my team has approved. I don't believe in just willy-nilly allowing people to directly download from Docker Hub. I don't recommend that for anybody. You can use a multi-stage build, selectively copying what you need in the image. That's recommended. That way it means your image is tight. It doesn't have a lot of unnecessary layers in the container image. Without using a base or parent image, not a lot of people do this. You can build the whole entire OCI compliant image yourself if you're super paranoid, using a tool called Builda. It's kind of a pain. Maybe in a very strict environment, finance or government, you might do that. You can also, I highly recommend this technique, creating a single layer image it's called from scratch. It's essentially a no-op. You're using a statically compiled binary. I will warn you, security tools actually error out on this. I don't want to mention any names specifically, because it's not that the security tools are bad. They just don't know what to do with this from scratch image, because it's basically a no-op, right? You can create a distroless image that only includes an application and runtime dependencies. That's also a recommended technique. I will tell you, I have run into people who will actually disallow from scratch or distroless images. Please don't do that, because that's your developer doing the right thing. We want to support them in doing that. And while I recognize that security tools may just hang on that and throw some errors, I think we need to be smart and try to understand where the limitations lie, and try to cull that information and consider it a false positive. So we want to use the best ingredients, right? You want to use, as I mentioned, you want to use a trusted source for the base images. You want to validate the image with a container security tool, and you could combine that with software composition analysis. I always see a lot of pain on this topic, because there will be fighting. You will have software composition analysis tools such as a white source or a black duck. They are container aware. That means they understand the format of a container. A lot of those tools may not always be container friendly and container security aware, like a container specific tool, like an Aqua Security or a Twistlock or whatever. That's one of a container security aware tool will understand and look at the actual configuration of the container options and how it's been built, or it might look for secrets. It might look to see if there are processes that try to run as root in the container. So I don't have a problem with layering those tools, and I don't think you should either, but you need to be aware of where the overlap is and where you might have to deduplicate or resolve any inconsistencies in the findings. Economize. You want to make sure that your developers understand that economy is security, right? You want to only add elements necessary for delivery of the application. You want to follow a least privilege model. You don't want to run root processes. You don't want to run the container as privileged. You want to limit syscalls. While seccomp is recommended, at container runtime, I'm not going to lie, it's not always for the faint of heart to configure. There are some default seccomp profiles for Kubernetes, but again, if you have heterogeneous compute as opposed to homogeneous compute, you're going to spend some time on this. You want to make sure your developers are parameterizing configs, right? You don't want to hard code things like, you know, you don't want secrets in there. You don't want networking elements in there, you know, specific IP addresses, whatever. You want to parameterize where you can. Don't, please, for the love of God, don't have a shell on your container, and don't allow your developers to log into containers. That is just really a bad practice. Remember, containers are cloud native technologies, which are about immutability and ephemerality. So you want to make it so that you can easily, that these are fungible and replaceable at the drop of a hat, right? You want to minimize through techniques like distroless or from scratch, and automation. Your best protection is as much automation as possible, so that you need to replace it. You have vulnerabilities that you've discovered in libraries in your container. You should be able to update it, redeploy, update, redeploy. In fact, I've worked at places that had TTLs on running container instances. For example, 2 weeks, and then it's drain or evict, you know, on Kubernetes. So let's talk about different techniques in terms of running containers. Fry, bake, buy. So probably a lot of people here are familiar with terms baking versus bootstrapping with, you know, AMIs or virtual machine images. So like bootstrapping is where you have a base, AMI, and you layer on, you bolt on the applications and any configurations at runtime, right? That's a legitimate, you know, it can take time to create a full library of baked images. Well, you have the same kinds of concepts with containerization, right? You have frying, which is custom built or extended third-party images. They're deployed, but they are changed during bootstrapping activity. So the problem there is you can't attest that. You could prior to deploy, but it's not really the same thing. And the things that you need to look for are if a container does an apt-get at runtime, or it does a curl. Those are not good decisions to make in a running at runtime, right? Baking is a custom built or extended third-party image. It's ready to go. It's fully parameterized. It's fully created with all your dependencies as part of the supply chain. It's read-only, right? It's immutable. You also have buy, where it's a third-party or vendor image and it's deployed without changes. I mean, that's kind of rare, but it happens. Okay, so basically, just like food, you don't want it fried. You really, I want to emphasize that, because you can't really attest to it. It becomes problematic in the supply chain. Here's an example of a typical container security validation process. I'm just going to walk you through it without getting into, you know, too much detail, because it becomes a little dry. So I have 1A or 1B. So 1A is a third-party image that's downloaded or mirrored from a public repository to an internal repository. Remember, I pointed out that was the best way to do it. You use mirroring so that you can contain and restrict what people have access to. Then you use it as a base image, and then I like to say you fork it with a custom layer, right? Again, I just added some, you know, tools that you may be familiar with in part of that process. 1B is a custom image built internally and then uploaded to an internal repository. But basically, whether it comes from outside or whether you generate it inside, you're using, it's really key here. If I haven't really, I didn't overtly say it. I think I said it a couple of places implicitly. If you have more than one container repository, if you have multiple source code repositories, if you have multiple artifact registries or repositories that aren't related, you've got a supply chain issue. You, as an application security individual, will need to, you need some level of assurance about where the source material comes from. So we want to have some consistency of let me be clear on the difference between a registry and repository for containers. A registry is a holder for multiple container repositories for different software projects. So you want to have unified registries. They may have multiple repositories, but you want to make sure that these are something that are controlled by the organization. You don't want just random repositories and registries all over the place, right? Sorry for that segue, but I wanted to make that clear. So the important part for a supply chain and for DevSecOps and how you do perform validation is that you want a decision, right? It's the idea of a decisioning principle and a set of decisioning criteria. So as a security professional with authority and oversight for this process, you're going to establish some criteria, some base criteria for pass, fail, when you're going to block, when you're going to allow, right? So what I typically do is a CVSS score. You can say 2 or 3, whatever you've standardized on. We can have a religious argument about what that means and what's preferable. But I usually say it has to be less than 7, right? I'm going to say, okay, I'm going to fail you I'm going to block you if it's an 8. If this cumulative CVSS score is 8, I'm going to say no root-owned processes in the container image, and you better not try to run as privileged, and it shouldn't have a shell installed. That's just a very, crude set of criteria, and then I'm going to check for that, in multiple phases. Like when you upload the image, the container image to your repository, maybe I initiate a scan. Okay, maybe when I'm gonna check as part of CICD when you try to deploy the container. Oh, do I know that image? Did I scan it? If I didn't scan it, I'm gonna go scan it now. Oh, I already know it and I scanned it and the cumulative score was 8. Fail. We're done. Have a nice day. Do not pass go. Do not collect $200. If you pass all that criteria, great. Now you're going to go on and you're going to get to runtime. And maybe I have admission control, maybe I don't. But I'm going to have some kind of runtime control component that ensures that you passed all the other gates, that you're security validated, signed, and you can be deployed. So now that leads into a really important discussion point that I'm sure everybody has heard about: container orchestrators, right? You've heard about Kubernetes. Kubernetes is the hot new thing that all the cool kids are playing with right now. It's not necessarily that new. You previously, before Kubernetes, you had something called Nomad, which is a perfectly reasonable tool to use for container orchestration. But let's talk about what a container orchestrator is. Handles the deployment and runtime lifecycle of running instances. It can automatically scale instances up and down to meet demand. It offers redundancy, availability, for running instances and hosts. It can provide some segregation through namespaces and steering of workloads to preferred nodes or clusters. It provides load balancing, service discovery, health monitoring. You have the ability to create virtual clusters and granular management of resources. You can do multi-tenant segregation. So for example, when you use ACI or ECS, you're likely using in Azure, you might be on Kubernetes, right? And same with AWS. Examples: Kubernetes, OpenShift, Mesos. Again, Mesos is probably an earlier technique. You have cloud provider managed orchestrators such as EKS, Amazon Elastic Kubernetes Service. You have GKE from Google Cloud. You have the capability to use policies with an entry point that ensures only instances that pass are allowed to run. It used to be called pod security policies. I left it on there because technically you can still use it, but pod security policies has been swapped out for full admission control. You'll hear this a lot. It's called an admission controller on Kubernetes, and it uses a pod security standard. You also have security contexts, which are per pod. The takeaway for you is there's something called admission control. It's an admission controller. You either have a validating or mutating admission controller, and it is your gate. And that is a very important final gate that says, here's the criteria. I really hope you met it, because if you don't, you're not going to run and you're going to fail. That's a really important thing to understand when you're talking to development teams or Kubernetes operators, because you can validate that it meets the criteria that you want. So speaking of Kubernetes, I want to pull up and put it in the context of cloud native, right? Cloud native, a lot of times you'll hear it discussed as being, oh, well, that just means that it's in the cloud. No, cloud native is, and you can look up the cloud native concepts of 12-factor apps, right? I recommend that you look into that. But the CNCF is the Cloud Native Computing Foundation, and they've established the principles of cloud native, which is microservices. It emphasizes containerization and container orchestration, those concepts of ephemerality and immutability. And they actually have a really wonderful document on supply chain security. I encourage you, in the references, I've included a link to that document. I'm part of, I attend intermittently the CNCF tag security, which is an interest, it used to be SIG, special interest group, but they changed it to tag, and now I can never remember. I think it's technical, no, it's TOC, Technical Oversight Committee or something. Anyway, the idea is that this white paper talked about establishing and verifying trust at every step in the process through a combination of code signing, metadata, cryptographic validation, everything that can be automated should be automated, because remember what I talked about is that it's harder to make a mistake or intercept or interrupt something if it's automated. It's going to be very obvious if a process is automated and somebody tries to dork it, right, and try to intervene. Automation helps prevent accidental errors, and it makes it much easier to spot when things have gone wrong, right? Provide clarity. Every step in the software build and supply chain process should be clearly defined with a precise, limited scope. Remember how I mentioned that the SDLC is business rules, right? That's really what it is. Every time I go into a new workplace, a new shop, I ask the same question. Let me see your SDLC. Let me see your pipelines. Let me see your subway map. I've heard people refer to the build lifecycle as a subway map. I want to see it written down. If you get a bunch of developers who say, it's in the code. We didn't write it down because we're agile. We don't do that. So first of all, that's a lie. Agile is not about not doing documentation. Go look at the Agile Manifesto. It's just-in-time documentation. If they can't document that to provide clarity, then it's broken and you have a problem. You are likely to have a supply chain issue, and you are really likely to have a security issue. Every actor within the supply chain must have a clearly defined role. So good news, your automated supply chain, your cloud native supply chain, it automatically provides you with separation of duties. Isn't that amazing? it already gives you least privilege and separation of duties because it restricts everything in the automation. If it doesn't, and go back to the first step where you have a clearly defined, precise, limited scope, that's how you're going to figure that out. You can use automation and the supply chain to reinforce your governance, right? That's the good news. It makes your job easier. It allows you to limit permission of any systems or humans trying to interact. Recommendation, really strong. Every entity in a system must engage in mutual authentication. You should be using certificates within your Kubernetes ecosystem, for example. You shouldn't have humans involved. That's death to a Kubernetes deployment. Your software processes should engage in authentication. You need to trust but verify. That's what mutual authentication is for. I encourage you, if you are struggling to understand what's out there and what specifically relates to containers and the different tools available, the cloud native, the CNCF has a wonderful cloud native landscape, interactive cloud native landscape, and you can go in. This is a screenshot of just the security section. So let's talk about the different tiers of a technology architecture. Again, this is from a NIST document on an application container security. You have the developer systems, right? A lot of developers still create containers on their desktops. That should be discouraged for production, not for their own development testing, but you probably want to discourage that. But the main phases for image creation and accreditation, you have image storage and retrieval, you have container deployment and management, and here's the flow of how that works at a very abstract and high level. You see the registries where the containers are placed. You see the orchestrator, and then you have a node or a container host with the running instance. So what's in your kitchen? This is, I'd like to say this is mine, but this was a collaborative effort at a place that I worked. And this was, I think what I'd like to say about this is it represents a lot of what should happen in a container supply chain, a collaboration. This was a collaborative effort between the development community and the development platform team, the enterprise architecture team, and the cyber architecture team of a place where I worked. And so because when you're developing container security, I think it's really important that you understand it's not like it used to be. It's security and validation is very integrated into the entire supply chain. So let's just walk this through. Again, you have a developer who pushes code that triggers a build. You'll notice I have a policy validation service and an image security validation service, right? You may have other policies that aren't necessarily security policies, right? You may have criteria for release management or for the, maybe you want to check, maybe you want to make sure that the versioning reflects SEMVer, right? Semantic versioning. That could be a policy validation criterion that you want to validate. So, but then you also have, again, you have image security validation that happens as well. It could be even the same system, but it's a separate set of business rules. I think that's what I'm trying to reflect here. Then you'll publish the image, right? You'll notice that I have, on this slide, I have a non-prod registry and we have a prod registry. We had different sets of rules in the way you interacted with each of those. and you signed and distributed for each. And we were trying to create a promotion or a distribution mechanism for those images. So now you have, let's say first you go to non-prod and you have a non-prod Kubernetes cluster that pulls the image and it does additional testing. Maybe you have some functional testing that needs to occur that isn't related to security specifically, but you could have security testing there as well. You submit the testing evidence, you have a release management system, the release decision comes, yes, you've hit all the security checkboxes, you've also hit other policy checkboxes, we've decided you may release, go ahead. And then you get promoted, it triggers a release from the core image registry, and then it's distributed to production environments. But you'll notice that the bifurcation, right? There's a core image registry that doesn't actually touch the production environment. It is, it's farther to the left, and then images are promoted from that. And that gives you an opportunity to ensure that you've minimized the attack surface by having read-only registries that actually touch running environments, right? It means that it's less likely that somebody can modify, an image before it's running, and it's less likely that you are going to have something that you haven't fully attested in production. Okay, that was a lot of talking. I'm sure you're mentally exhausted from all the information, because I always end up giving you more information than you actually need during these talks. I just want to give you some reminders of what I've covered here, right? Small is beautiful. You want compact, tight images. You want to leave out unnecessary libraries and binaries. This is a mentoring opportunity for you. When you work with developers, they're just going to initially, the level of maturity is throw everything in the container, including a shell. You don't want that. And here's an opportunity to have a conversation, right? And mentor somebody in proper behavior, right? You want to validate your images. They should be free of vulnerable libraries and components, right? At least you want to have your defect management, SLA in terms of, okay, maybe the component scores, the vulnerable component is a 3, a CVSS 3. Well, if you have a 2-week TTL on your running instance, then they will likely be able to remediate that before you hit the SLA, right? The defect SLA. So keep all of that in mind. You want to have some criteria for pass fail, right? You don't want to say, I worked in a place once where they said no vulnerable containers. Well, that's not very realistic, right? So container images shouldn't need to run as privileged, because let me tell you, if you've never played with container breakouts, container escapes, if a container runs as privileged and somebody gets into a container, which it's not, it's like getting into a system through the front end, a vulnerable web application. It's not that hard. You can do it. It's not hard to do. If that container runs as privileged, it's game over for the host and for every other container that runs on that container host. That's really not where you want to be, so please pay attention to that. You also don't want processes that run as root, and you don't want a container that runs as root. So don't put credentials, keys, tokens in your image, please. First of all, they're going to be stored in a repository, and it's trivial to mount that container and get what you want from it. But it's bad practice, right? You want to reduce the listening ports needed on your container image. Yes, this isn't, a virtual machine, but it does use listening ports, so let's try to keep that minimal. You're just increasing the attack surface and resources that need to be secured. Use a standard runtime. It's run C, container D. Don't try to go off and use something else because you think it's cool. You want to be mindful of what your current security tools are and whether or not they support that, what versions they support. It's the same with orchestrators as well. If you're going to use Mesos, okay, how are you going to secure that, right? If you're using a managed container orchestration system, you also want to know how your container security tools are going to work on that platform. Again, container isn't a host. It's an ephemeral drop of rain. You shouldn't be logging in and trying to change it because it's going to evaporate, or it should. You want attested, immutable container images to run in your environment. And you want to constantly reevaluate your supply chain, verify source code, verify dependencies, protect pipelines and artifacts. And again, I not only have 1 page of references, 2, 3, 4. I think that's the most reference slides I've ever had in a presentation, and it's mostly because I know this was a lot of material. I know it's very complicated, and if you haven't done a lot of systems work in the past, it may be, it's a lot to take in. So I want to appreciate everybody's time and patience, and I want to now open it up for questions. Is that what we're going to do now, Helen?
That's amazing. Yes, we have some questions, and thank you for this wonderful session. I really loved your analogy with food. It really was entertaining to and try to understand this complex topic with simple recipes. Like you said, yeah, make sure you don't use shells. I'd say, yeah, you don't want any eggshells in your cake, right? That's not that kind of crunch you want to get.
I'll steal that. That's really good.
Yeah, so it's so much information. I almost feel I have to go back and listen to the session again, because every slide is packed with what you say and what. No, don't be sorry. But I'm saying that it's a good idea. And frankly, we're going to have this session on demand, so anyone can actually go and pause and listen and think through that. That's important. Anyway, let's go through the questions because we have some.
Hopefully I can answer them.
Yeah, so first of all, we have Larry, who is, I think, right now listening on his phone. He is very excited. I'm sorry, I don't know, Larry. This person is very excited to be here. That person knows you actually for years.
Oh yes, I have friends on this as well. I wanted to pack the audience so I wouldn't get heckled.
Anyway, we have a question. So first question is it safe to assume that containers can all share the same IP address, but virtual machines require separate IPs?
Container networking, I did not get into that a lot because it'll make your brain bleed out of your ears. Okay, yes, at the most basic level, that can be true. You have the option, though, in Docker, you could do bridge networking or routing. That's one of actually the benefits of a container orchestrator, such as Kubernetes, is you have a full network stack. It's not truncated the way it is without a container orchestrator. So you have the option of full routing using BGP actually, or you can use overlay with VXLAN, which is a familiar network technology that you'd know from virtual machines, right? So the answer is it depends, but you are not going to have the same kind of network isolation. I think that's fair to say that you would with virtual machines. And I think what you need to be very mindful of when you're investigating what the architecture is of container deployments in your environment, you need that needs to be a lot of questions that you ask. I typically, when I go in and I look at a Kubernetes system and an architecture, I'm like, what are you doing, routing or overlay? If they go, what? If they go, I don't know what you mean, you're like, hold up the big red stop sign, you've got a problem. Because that means that means they picked a default and they don't understand it, and there was no intentional design of the network, right? With and then they're probably not using network policies, which are like kind of security groups for your pods so that they can't talk to each other. Luckily, in fact, one of the benefits of OpenShift is that the default, I think, is if you use God, I forget the term, but by default, there's a default option that will prevent pods communicating with each other. The term escapes me, but if you look it up, it can do that restriction if you choose overlay technology as opposed to routing. But I think, I'm sorry, I probably gave you a bigger answer than what you were looking for. But the root is, it's complicated. You need to look at it. Yes, at a very simple level, that is true, but it can be much, much more complicated than that.
Well, thank you. I think it's...
I probably hurt your head, probably answering that too deeply the way I did.
There are several follow-up questions as well. So the client or user space part of an APP is not in the computer, or only the shared libraries?
You mean in the container itself? I'm sorry, I'm not following the question quite. Maybe I'm...
Yeah, I think the question was during one of the slides. I don't remember which one. It was related to the slide. And then there is a follow-up, and server modules is yes. Maybe we can get back to that.
Yeah. I'm not quite following the question.
Okay.
I can.
Are pre-built containers signed? And does OAuth and OpenID play here? Would be great to use federated ID for containers.
So I think when you're talking more at the application stack level when you're talking about OAuth and things like that. Yes, you can have your containers signed. For example, I just want to go back to this slide so they have that. Sure, you can have, there's Notary, there's Artifactory has a way of signing containers. There are all kinds of ways, and I would recommend it. I would recommend that your containers are signed so that you have some level of trust, right, associated with and read-only and immutable quality with your containers. So that's what I would recommend. Yes, you can do that. You will likely get pushback. I'm not going to say it's painless. It certainly is not. Especially if you try to do something like if they're doing frying of the container, then you're going to have problems as well. But I recommend, and I put some references in there. It's also on the Cloud Native, the CNCF security landscape. There's a slide that talks about, there's a section that talks about Notary, but you can integrate that. It was sort of a lot of detail to go into that. I didn't, this was only an hour. I would have done that as part of a workshop, maybe. Is that helpful?
I think it is. I also almost wishing maybe if you have a blog or an article with all the references as well, it would be also a good thing.
I will put this up on SlideShare at some point. I'm gonna also, I'm doing this a couple other places, this talk, so eventually it'll end up on SlideShare. But I'm happy to share it with the listeners here as well.
Okay, so I guess if anyone else, I know it's a lot of information, right? And we already over time.
It is, and some of that's my fault, right? Because I had the issues before, but I hope that this provided at least a starting point. And Helen, I'll share the slide deck in whatever format you want, so that as a PDF, so that it has all the references, so people can research that on their own. There's great material out there, but I won't lie. I think the takeaway that you need to internalize here is that containerization is highly complex now, especially with the introduction of Kubernetes. I initially got stuck with doing cloud native technologies and making that my area of expertise, my control domain, because nobody else wanted it. I have had application security friends, I would explain what Kubernetes was, and I would go into all the details of an architecture, Kubernetes architecture and security control architecture. And they'd go, oh my God, I don't want to do that. That's horrible. It's so hard. It's so complicated. I'm not doing that. In fact, one place when I left, nobody wanted to take over the control domain. It's like, it's still not taken over. So I'm not going to lie. I'm not trying to scare you, but be prepared. You will spend a lot of time here. It's a rabbit hole, but it's what is right now. This is what developers want to use. You can think what you want about it. We can talk about the benefits or the, how much it really makes our job harder. Offline, that's probably a philosophical discussion, but it's what is. So I encourage you to become very fluent in this technology.
Well, Larry mentioned in a comment that Larry is parked and listening, and says that Michelle's answers were right on target. Thank you very much, Michele.
Great. I appreciate it. Okay.
Okay, I think we could continue this discussion for another hour at least.
Yeah.
And Michelle's comment about not running containers in privileged space just made me feel like an idiot.
No, don't. I mean, if you can find, there's some great, I did not include them here, but if you just look up on any, a container capture the flag would be an awesome thing to do, for the community. I think if you get that, if you get a chance to do a Kubernetes capture the flag, I highly recommend it. There are also different platforms. If you just look, they're free platforms where you can go and play around, and they even have there's a KubeGoat, a vulnerable version of Kubernetes. And FYI, there was a major vulnerability identified on the Azure ACI platform where a group of white hat hackers proved that they could compromise the Azure container infrastructure. I encourage you, it's a Code 42 article. You can look it up. Code 42, the Palo Alto research team, and Kubernetes and Azure. You'll find it. It's a great article. It's almost like a perfect test case for what not to do, like how you can compromise it. So I recommend that. I'll add it to my references as well.
Thank you. Well, thank you very much for this insightful session, Michele.
No, thank you for the opportunity. I appreciate it.
Thank you. I think we will wrap up on this happy note. Thank you, CyberX, for hosting leading cyber-related sessions, and for everybody who attended. Please stay in touch. We'll have another session coming up soon, and see you next time. Bye, everybody.